Hey guys, welcome back. Trying this on my phone this time, so we'll see how this goes. I think it will be a little better as far as like the timing and everything. The last one, I think my speech might have been a little off, like the timing on the video. So we'll see if this works a little better. So I hope you guys are having a good week. We're on to lesson 102. So we're going to talk about mass and weight today. So mass and weight seem very similar, but we're going to talk about, the slight difference between them, the units of measurement for both, and then we'll just look at a couple of short examples. So this is going to be a pretty quick lesson, but I've got a couple of little examples I want to show you real quick, so while we talk about it, and then we will get started on working some examples. So let's look at, let me just pull this up real quick. All right, so mass, if you look here, we can see that mass, I've given you 3 examples and then listed like their actual weight. So for mass, we use the metric system to measure mass. And also mass is the physical, the amount of matter in an object. So if you want a quick definition, you can write that down. Mass is the amount of matter in an object. And so we see that we can measure mass by grams. So a milligram is like teeny tiny, literally about the size of a grain of sand. Okay, and there are 1,000, remember your prefixes here, 1,000 milligrams make up 1 gram. So 1 gram is about the mass of a paperclip. So that means it takes about 1,000 grains of sand just to equal the mass of a paperclip. That's pretty crazy. Then you've got a kilogram, which if you remember, a kilogram is 1,000 grams. So if you stacked up 1,000 paper clips together, it would weigh about the same as a textbook, which I just so happened to pick the textbook that you guys will be doing next year. Just a little preview. You're getting close. Hang in there. So that is mass. So let's look at weight and how weight is a little different. So we're going to flip over here. Oh, let me clear that one out first, actually. Clear that one out, and then we'll flip over to looking at weight. So for weight, we use the customary system. So we're going to talk about ounces, pounds, and tons. The difference between mass and weight is that your mass is universal, so your mass never changes, okay? Now, weight can change based on the gravitational pull. So think about it like this, like whenever astronauts travel to space, they become weightless. That means their weight changes. Here, an astronaut might weigh 180 pounds, but in space, they weigh nothing. They become weightless and they're able to float around. That's because there's a lack of gravitational pull. So the gravitational pull can affect weight. It does not affect mass. Your mass never changes because it's like your actual makeup. So it's a little different, subtle differences. Okay, so let's talk about these and just kind of show you an example of each. So an ounce is about the weight of a envelope. Okay, so if you ever felt an envelope that's empty, that's about an ounce, pretty light. A pound, which is made up of 16 ounces. So let's actually put that on here because I did not put that on here. So a pound is equivalent to 16 ounces. No, ounces is abbreviated OZ, which you guys should already know, but just in case you don't. A pound is about the weight of a shoe. So, any of those shoes in your closet, I'm sure you got at least one. That's going to be about a pound. And then a ton could be the measurement of something like a small car or truck. So a ton is actually made up of 2,000 pounds. So just a quick note, notice that the conversions here are slightly different than the conversions before, because before it was like 1,000 milligrams make up a gram. 1,000 grams make up a kilogram. So it was a very standardized conversion rate. Here we're dealing with some very different conversion rates. Like we've got 16 ounces make up 1 pound, and then 2,000 pounds make up 1 ton. So it's not quite as universal. It's just one of those things, one of those conversions that it would be really good to memorize though, guys. Okay, there's my tip, because trust me, these are just going to keep showing up. So that would be a really good idea right now. Okay, so let's go ahead and do a couple of examples. So we're going to look at this first question. 2 kilograms is how many grams? Well, we just talked about the fact that 1 kilogram is equal to 1,000 grams. So if 1 kilogram equals 1,000 grams, then it makes sense that 2 kilograms would equal, you guessed it, 2,000 grams. Sorry, my hand's in the way. I don't know why it's doing that. Okay, awesome. All right, let's look at the next one. So that was a pretty basic question. We've got one more on here. So now we've got, oh, I thought we had one more. Just kidding. Actually, don't have it saved, so we're just going to write it out. Okay, so now we're going to add, let me get to it right here. We're on page 552 for those of you that are following along in the book. So first we're going to add 7 pounds. 12 ounces to 2 pounds and 6 ounces. Okay, so we're going to add these. So when you add these, you always want to start on the right, just like in normal addition. So we're going to add the 12 and the 6, which would give us 18 ounces. Then we're going to add the 7 and the 2, which would give us 9 pounds. Now, normally that would be our answer, but we always have to check to see, okay, can I convert any of my ounces into a full pound? Well, we just talked about the fact that we know the conversion rate that 16 ounces equals 1 pound. So we do have more than 1 pound here. So if we were to break that down into the 16 that make up 1 pound and then the 2 that are left over, we could take this 16 and add it as 1 pound to the 9 pounds. Okay, so it's just like carrying. So we're carrying a 1 pound over, making it 10 pounds. And now we only have 2 ounces left. And that would be it. So let's look at one more similar to that. So this time we're going to subtract. So we're going to do 9 pounds. Oops, sorry. Not really sure why that's. Hold on, just having a hard time getting that one on there. Let's try that one more time. So we're going to take 9 pounds. You're just not going to be able to see my face for a second. Sorry, guys. 10 ounces, 7 pounds, 12 ounces. So we're going to subtract this. Now, if hopefully you have already looked at this and you already see a problem, can we take 12 away from 10? Can't do it. It's not big enough. So just like in regular subtraction, we're going to borrow. So we're going to borrow from this 9 over here, which would turn that into 8 pounds. But remember, there are how many ounces in a pound? Yep, I know you said it, 16. Good job. So we're going to add the 16 because if we're borrowing 1 whole pound, that means we're borrowing 16 ounces. So we'll add the 16 to the 10, which would make that a 26. So we're actually subtracting 26 minus 12. So that is going to give us 6 minus 2 is 4, 2 minus 1 is 1, so 14. And then 8 minus 7 is 1. So we are left with 1 pound and 14 ounces. Awesome. Great job, guys. That is it for this lesson. So just remember the difference between mass and weight. And then mass is not affected by gravitational pull, weight is. So mass is universal, does not change. And then just remember what we worked on here with our conversions. Study those conversions, get to know them well. They will keep showing up, and have an excellent week. Love you guys. Happy homework.